9.4, the quality of service models. Selecting an appropriate quality of service policy model. How can quality of service be implemented in a network? There are three models for implementing quality of service. The first one is the best effort model. The second is integrated services or IntServ. And the third one is the differentiated services or DiffServ. The table summarizes these three models. Quality of service is implemented in a network using either IntServ or DiffServ. While IntServ provides highest guarantee of quality of service, it is very resource intensive and therefore not easily scalable. In contrast, DiffServ is less resource intensive and more scalable. The two are sometimes co-deployed in network quality of service implementations. The best effort model, this is not really an implementation as QoS is not explicitly configured. This is use this when quality of service is not required. And the second one is the integrated services or the IntServ. This provides a very high quality of service to IP packets with guaranteed delivery. It defines a signaling process for applications to signal to the network that they require special quality of service for period that bandwidth should preserve. The third one is another description of the IntServ is the IntServ can severely limit the scalability of a network. The third one is the differentiated services or the DiffServ. It provides high scalability and flexibility in implementing QoS. Network devices recognize traffic classes and provide different levels of QoS to different traffic classes. The first one is the best effort model. The best effort, this is the basic design of internet, or the basic design of internet is best effort packet delivery and provides no guarantees. This approach is still predominant on the internet today and remains appropriate for most purposes. The best effort model treats all network packets in the same way. So an emergency voice message is treated the same way that a digital photograph attached to an email is treated. Without quality of service, the network cannot tell the difference between packets and, as a result, cannot treat packets preferentially. The best effort model is similar in concept to sending a letter using standard postal mail. Your letter is treated equally the same as every other letter. With the best effort model, the letter may be or may never arrive, and unless you have a separate notification arrangement with the letter recipient, you may never know that the letter did not arrive. The table lists the benefits and drawbacks of the best effort model. The first benefit is the model is the most scalable, and the drawback is there are no guarantees of delivery. Scalability is only limited by available bandwidth, in which case all traffic is equally affected. The drawbacks is packets will arrive whenever they They can, and in any order possible if they arrive at all. The benefits is no special quality of service mechanisms are required. The drawbacks, no packets have preferential treatment. It is the easiest and quickest model to deploy. And the drawbacks is critical data is treated the same as casual email is treated. The next one is the integrated services. The IntServ architectural model as according to RFC 1633, 2211, and 2212 was developed in 1994 to meet the needs of real-time applications such as remote video, multimedia conferencing, data visualization applications, and virtual reality. IntServ is a multiple service model that can accommodate many QoS requirements. IntServ delivers the end-to-end quality of service that real-time applications require. IntServ explicitly manages network resources to provide QoS to individual flows or streams, sometimes called microflows. It uses resources reservation and admission control mechanisms as building blocks to establish and maintain QoS. This is similar to a concept known as hard QoS. Hard QoS guarantees traffic characteristics such as bandwidth, delay, and packet loss rates from end to end. Hard QoS ensures both predictable and guaranteed service levels for mission-critical applications. As you can see in the figure, it illustrates the IntServ model. IntServ uses connection-oriented approach inherited from telephone network design. Each individual communication must explicitly specify its traffic descriptor and requested resources to the network. The edge router performs admission control to ensure that available resources are sufficient in the network. The IntServ standard assumes that routers along a path set and maintain the state for each individual communication. In the IntServ model, the application requests a specific kind of service from a network before sending data. The application informs the network of its traffic profile and requests a particular kind of service that can encompass its bandwidth and delay requirements. IntServ uses the Resource Reservation Protocol or RSVP to signal the QoS needs of an application's traffic along devices in the end-to-end path through the network. If the network devices along the path can reserve the necessary bandwidth, the originating applications can begin transmitting. If the requested reservation fails along the path, the originating applications does not send any data. The edge router performs admission control based on information from the applications and available network resources. The network commits to meeting the QoS requirements of the applications as long as the traffic remains within the profile specifications. The network fulfills its commitment by maintaining the per flow state and then performing packet classifications, policing, and intelligent queuing based on that state. The table lists the benefits and drawbacks of IntServ model. First off, if the benefits is explicit end-to-end resource admission control, and the drawback is resource intensive due to the stateful architecture requirements for continuous signaling. For the benefits, pre-request policy admission control, signaling of dynamic port numbers. And another drawback is flow-based approach, not scalable to large implementations such as the internet. The last one is the differentiated services. The differentiated services or DiffServ QoS model specifies a simple and scalable mechanism for classifying and managing network traffic. For example, DiffServ can provide low latency guaranteed service to critical network traffic such as voice or video, while providing simple best effort traffic guarantees to non-critical services such as web traffic or the file transfers. The DiffServ design overcomes the limitations of both best effort and IntServ models. The DiffServ model is described in RFC 2474, 2597, 2598, 3246, 4594. DiffServ can provide an almost guaranteed QoS while still being cost-effective and scalable. The DiffServ model is similar in concept to sending package using a delivery service. You request and pay for a level of service when you send a package. Throughout the package network, the level of service you paid for is recognized and your package is given either preferential or normal service, depending on what you requested. DiffServ is not an end-to-end QoS strategy because it cannot enforce end-to-end guarantees. However, DiffServ QoS is more scalable approach to implementing QoS. Unlike IntServ and hard QoS, in which the end host signal their QoS needs to the network, DiffServ does not use signaling. Instead, DiffServ uses a soft QoS approach. It works on the provision QoS model, where the network elements are set up to service multiple classes of traffic, each with varying QoS requirements. The figure shows a simple illustration of the DiffServ model. The DiffServ model the DiffServ divides network traffic into classes based on business requirements. Each of the classes can then be assigned different level of service. As the packet traverse a network, each of the network device identifies the packet class and service the packet according to that class. It is possible to choose many levels of service with DiffServ or DiffServ. For example, voice traffic from IP phone is usually given preferential treatment over all other application traffic. Email is generally given best effort service, and non-business traffic can either be given very poor service or blocked entirely. As you can see in the figure, the benefits and drawbacks of the model are: the modern network primarily use the DiffServ model. However, due to increasing volumes of delay and jitter-sensitive traffic, IntServ and RSVP are sometimes co-deployed. So the benefits of differentiated services are, the benefits is this is highly scalable and provides many different levels of quality. And the drawbacks are, no absolute guarantee of service quality. It requires a set of complex mechanisms to work in concert throughout the network. So next off is the QoS implementation techniques.